Hello and welcome back to this channel. Dear students, today's session is Operations on City Signals Part 2. Earlier, we have completed Part 1. Let us solve some different numericals related to operations of city signals. As I mentioned in the earlier video, you just have to remember only two rules. If inside the bracket opposite sign is there, shift diagram towards right. It is SR, means shift right. And if inside the bracket same sign is there, shift diagram towards left, that is SN. Now the question is, perform following operations on the signal. Signal is given as x of t is equals to u of t plus 4. U of t is a unit step. For the reference, I have drawn the diagram of u of t, that is unit step. It is from 0 to infinity and its amplitude is 1. Let us first sketch the signal u of t plus 4. Check the signs inside the bracket. It is u of t plus 4, that is plus t plus 4. So same sign means shift diagram towards left. Which diagram we have to shift? This diagram, which is the diagram for u of t. I have to shift it towards left by 4 position. As we discussed earlier, always and always stick to the rules. Start reading every diagram from left to right. This diagram of u of t starts from 0. I have to shift it towards left by 4 positions. So new diagram will start from minus 4. So let us say I have the reading of minus 4 over here. So new diagram will be, amplitude will remain same, that is its amplitude is unity. It will be till infinity, but only starting point is different because I have shifted this diagram towards left by 4 positions. So this is the diagram of x of t, which is u of t plus 4. Now first part, it is asked to calculate or sketch z of t, which is x of minus t minus 1. X of minus t minus 1. Now don't get confused as far as this notation is concerned. First we have this diagram of x of t. First we will try to draw the diagram of x of minus t. This is not a discrete signal. For discrete signal, we are supposed to write the sequence and then draw the diagram. This is the case of continuous diagram, so you have to directly draw the diagram. First, what I will be doing, I will be drawing diagram of x of minus t only. Keep in mind, I have to perform the operation x of minus t minus 1. But first, I will draw the diagram of x of minus t. Do remember the notations. X of t is the original notation. X of minus t represents folded version. Folding means mirror image. This diagram is from minus 4 to infinity. I will write it here. It is from minus 4 to infinity. If you fold it, if you take mirror image, then mirror image of this will be from, just change the signs. Since it is minus 4 to plus infinity, it will be from 4 to minus infinity. So let us draw the diagram of x of minus t, which will be from 4 to minus infinity. Say this is the reading of 4. So the diagram will be like this. Amplitude remains unchanged, which is 1. So new diagram of x of minus t will be from 4 to minus infinity. Rather, minus infinity to 4, because our rule is start reading the diagram from left to right. So I will say minus infinity to 4. Amplitude is 1. This is the diagram of x of minus t. I am not directly drawing the diagram of x of minus t minus 1. First, I have drawn the diagram of x of minus t. Then, think like this. It is x of minus t minus 1. So minus minus is again same sign. Same sign means we have to shift the diagram towards left. By how many positions? By 1 position. Do not get confused. This minus sign is just indicating whether shift left or right. In this case, it is shift left. 1 is the amount by which I have to shift the signal. So this diagram of x of minus t, I have to shift towards left by 1 position. Why left? Because it is having same sign. Minus minus is same sign. So shift left. This diagram, I will have to shift left towards left by 1 position. This diagram is from minus infinity to 4. Rather, it is till 4. If I will shift it towards left, it will be till 3, because minus infinity will remain as it is. So if we want to draw the new diagram, then new diagram of this thing z of t, which is minus x of minus t minus 1 will be, since it is diagram till 4, I have to shift it towards left by one position. So new diagram will be till 3, amplitude remains as it is. So 3 will be the ending point, minus infinity will be the starting point, because minus infinity plus minus anything will give you the result minus infinity only. So this is the diagram of z of t, that is x of minus t minus 1. Now let us solve the second part. In the second part, it is asked to perform this operation x of t plus z of t. I have the diagram of x of t, second diagram we have generated, that is diagram of z of t. So I have to add these two diagrams. Now how to do it? First let us mark the scale. So this is the resultant diagram for y of t. Y of t is indicating addition of x of t plus z of t. Now how to think? This diagram, first diagram of x of t starts from minus 4. That means before minus 4 it is 0. But this diagram is starting from minus infinity till it is plus 3. That means think like this. Since this diagram starts from minus 4, but this diagram is starting from minus infinity. So let us say somewhere I have this reading minus 4. So from minus infinity to minus 4, only one diagram of amplitude 1 will be existing. So I will mark the scale over here. Say this is minus 4, another scale is 3, 4 and so on. Remaining scales are not required, so I haven't sketched it. Now what I said, this second diagram is existing from minus infinity to minus 4, where the first diagram is 0. So first I will complete this part. So this diagram starts from minus infinity till minus 4, its amplitude remains 1. Say this is the level of amplitude 1. Now at minus 4 this is 1, at minus 4 this is also 1, so 1 plus 1 becomes 2. So at minus 4 this amplitude becomes 2. Say this is the level of amplitude 2. At minus 4 this is 1, at minus 4 this is also 1, so 1 plus 1 becomes 2. Now onwards till 3, the second diagram's amplitude is 1, but this diagram's amplitude is 1 till infinity. So till 3, 1 plus 1, you will get 2, amplitude 2. So till 3, I will sketch the signal, same signal of amplitude 2 till 3. Now after 3, the second diagram becomes 0, whereas after 3, let us say this is 1, 2, 3 till infinity. So after 3 till infinity, only one diagram is existing. First diagram, it is having amplitude 1. So after 3, this is the level of 3. This was the level of minus 4. So after 3, amplitude becomes 1. So the diagram is like this till infinity. So this is the resultant diagram of addition of x of t plus z of t, which is denoted by y of t. Let us solve one more complicated numerical to get the detailed idea. The next problem is a CT signal is shown in figure. This is the given figure in the question, which indicates signal x of t, and by default on this axis notation will be t. Sketch the following. These are the 4 parts we need to sketch. Let us talk about first part. Keep in mind the rule remains same. If inside the bracket opposite sign is there, shift diagram towards right. If inside the bracket same sign is there, shift diagram towards left. So the given diagram x of t is having amplitude 1 and it is from minus 1 to plus 1. First part, x of t minus 3. Look at the signs. It is t minus 3, that is plus t minus 3 plus minus opposite sign. Shift diagram towards right. By how many positions? By 3 positions. Again, don't get confused for this minus sign. This plus or minus sign indicates whether we have to shift the diagram towards left or towards right. In this case, I have to shift this diagram towards right by 3 positions. This diagram starts from minus 1. As I mentioned earlier, read each and every diagram from left to right. So diagram starts from minus 1. I have to shift entire diagram towards right by 3 positions. So if we want to sketch this diagram, then every point will be shifted towards right by 3 positions. So how to make it more simple, this limit is minus 1. So let us perform the simple calculations like this. Minus 1 plus 3, because I have to shift it towards right by 3 positions. So go on adding 3. So minus 1 plus 3 will give you amount to Similarly, this limit is 1 because the diagram is from -1 to +1. So it ends at 1. So ending limit is 1 plus 3 will give us simple 4. So the resultant diagram will be from 2 to 4. So let us mark some scales 0, 1, 2, 3, 4. So resultant diagram will be from 2 to 4, whereas amplitude remains as it is. That means amplitude is 1, it remains as it is. Only the position of diagram is changed. I have shifted this diagram towards right. So resultant diagram is x of t minus 3. Let us give some figure numbers to make the calculations easy. Say this is figure number 1. Second part, -2 into x of t. Make the thing simple. This is the diagram of x of t. Its amplitude is getting multiplied with -2. How will you come to know in the exam whether it is amplitude or time period t is getting multiplied? Very simple. Recall the things what we discussed in earlier videos. If notation is x of t, this t represents time period, whereas x represents amplitude of the signal. So it is -2 into x. That means amplitude is getting multiplied with -2. So make the thing simple. Time period remains as it is because it is -2 into x. Inside the bracket only notation t is there. So time period remains same. That means signal will be simply from -1 to +1 because time remains as it is. But amplitude, which is 1, it is getting multiplied with -2. So new amplitude will be -2. So I will draw the diagram like this. So new amplitude is -2. This is the diagram for the signal -2x of t. This is the second part. So give some figure number. Say on this axis by default it is t. So it is figure number 2. Now third part. This is the second part. Third part, x of t minus 3 minus 2x of t. Don't get confused. This -2x of t, just now we have drawn this diagram of -2x of t. This is figure number 2. X of t minus 3 is figure number 1. So it is simply as if you want to perform addition of figure 1 plus figure 2, because I have drawn the diagram for -2 into x of t, which is figure number 2. So I have to simply add figure 1 and figure 3. The addition is pretty simple. See how to draw the resultant diagram. First, let me mark some scales. So it is 0, 1, 2, 3, 4. This diagram is from -1 to +1, whereas this diagram is absent. So I will draw the diagram as it is from -1 to +1. Amplitude is as it is. Amplitude is 2. So this amplitude is 2, because this diagram is present from -1 to +1, whose amplitude is -2, whereas this diagram is absent in this part. Now this is the end of diagram at +1. This diagram starts from 2 to 4, whose amplitude is 1. Before 2 it is 0. So from 2 to 4 I will simply draw this amplitude as 1. This is the resultant diagram for the third part, that is x of t minus 3 minus 2x of t, say figure number 3. Now the last part, d by dt of x of t. Make the thing simple. I will tell you the simple rule while performing the derivative. Do remember the basics. D by dt of u of t. U of t is a unit step, is a delta function. Do remember this formula. Derivative of unit step is a delta function. And recall the things. Delta function is like this. At t is equals to 0, it is shown by an arrow like this. So this diagram is known as delta t, which is present only at t is equals to 0. Its area is very small and its amplitude is assumed to be unity. So it is shown by an arrow. Now we know this rule, d by dt of u of t is equals to delta t. But I don't have unit step, rather it is a unit step in the range. It is a step signal, unit amplitude signal from -1 to +1. So directly I am telling you the shortcut without increasing the complications. So if you want to perform derivative of this diagram, check the limits. It is from -1 to +1 and it is like unit step only, because amplitude of unit step is 1. Only difference is that unit step is present from 0 to infinity, whereas this diagram is present from -1 to +1. Since this limit is -1 and we know that it is similar to unit step only, so its derivative can be written as delta t minus 1 and second limit plus delta t plus 1. This is the simplest way to perform such type of calculations. Now if you want to draw the diagram for this part, what I said, just check the limits and write delta. So it is delta t minus 1 plus delta t plus 1. If we want to draw the diagram for this, make the thing simple. This is the diagram of delta t. Look at first part. It is delta t minus 1. Look at the signs plus minus. Plus minus is opposite sign. Shift right. That means I have to shift this diagram towards right by one position. So this diagram is present at 0. Let me mark some scales. So this diagram which is present at 0 will be shifted towards right by one position. So new diagram, new arrow will be here. This is for delta t minus 1, first part, and second delta t plus 1. Look at the rule, same sign, shift left. So I have to shift left this diagram by one position. This is at t is equals to 0. If you will shift it towards left by one position, it will be at -1. So diagram will be like this. This is the diagram for delta t plus 1. So this is the resultant part for the operation d by dt of x of t. Dear students, I have covered all the variations in case of operations of CT signals in the both parts, part 1 and part 2. If you haven't watched it yet, the part 1, do watch that video. I will provide the link in the description box. So thank you. Thanks a lot.